Hi, I am Namin Gunasegaran and my student number is 220534758, and I am going to explain the autonomous car assignment using Arduino and LabView. Below, these are the bullet points which explains what I did in this assignment and will be explained in this video. Here we can see the schematic diagram of the car, which has three ultrasonic sensors and one push button or micro switch, and light sensor, DC motor, and magnetometer, and also the servo motor. Servo motor is connected to Ackermann steering assembly geometry. Now we see the Tinkercad simulation for the Arduino. This is my circuit design, and I am using three Arduinos, which is this is master and these two are slaves. These two slaves are communicating with the master using I2C communication, and here there are three ultrasonic sensors using in this assignment, and this is one is for front and others are left and right. The straight is used for control the speed of the car, and left and right is used to maintain the position of the car. Next is the light sensor is used to control the headlights, which was located in front of the car, and this is the servo motor is used to control the vehicle or steer the vehicle left and right. And this push button is located at the has to be located in the bumper, and when the button is activated, the car will stop and the red light will glow for indication. Next is the DC motor, which is connected to L293D motor controller. To power the motor, we are using two 9-volt batteries which are connected in series. That power is used to run the motor. The motor RPM is set to 612 RPM, maximum RPM, and then we are going to see the potentiometer, and this potentiometer is connected to the slave 2, which is magnetometer Arduino. This potentiometer is used instead of IMU sensor because there is no IMU sensor in this simulator, so we are using potentiometer instead of IMU sensor. The third slave is used for camera, which takes reading from MATLAB because of using neural network, but we are giving inputs through the serial monitor for this to control the servo motor. Now we are going to see the simulation of the circuit, and when we start the simulation, we can change the sensor readings by using the sensors by clicking the sensors, and in the serial monitor, it updates all the display, all the sensor informations, including the LabView strings, which can be seen here. So now we are going to see now we are going to see the LabView part. This is the interface of the LabView, and in here it takes the 5 input strings from the Arduino, which was shown in the serial monitor. We can toggle the manual and auto mode here, and for manual, the ultrasonic sensors, light level and steering, everything will be shown, and also there will be some warnings, and for headlight also there is some LEDs for these. For when we toggle the autonomous mode, we have to give the range for left, right, and straight ultrasonic sensors, and also for camera input. If we change the sensor, if we change the value for the four inputs, the below there are some meters for left, right, straight sensors that will be also changing, and if we change the left and right ultrasonic sensors, the steering will be changed for according to the what we are given in the fuzzy logic. And also if we change the straight or camera input, it will also change the direction of the car and also the speed of the motor. And we also use the magnetometer to correct the vehicle, to correct the direction of the vehicle. When we given 3 directions, one is west, north and east, are given in this magnetometer using a knob, so which has been calculated in the block diagram. Now we are going to take in this input string we have to given the output from the Arduino, which is the 5 characters. This will be sent to the uh, split array. It will be split into the 5, and that will be inserted into the scaling factors, which do some calculations and gives the output as meters for ultrasonics and light sensor. And also if the ultrasonic left and right is less than 30, the side collision warning will be turned on. If the the straight sensor is connected to this is less than 30, the front collision warning will be turned on. And also for the last one is for headlight. It has two conditions, y and z. If y is displayed, y is 89 ASCII and z for 90 ASCII. If the input string is z, the light will be turned on. If the input string will be y, the headlight will be turned off. Here this is for motor speed control. This one, if the case is true, this will be connected to this one and doing some scaling factor, and gives the output as a string, which can be used in the Arduino, to control the motor speed. And also this also displays the how much percentage in a numerical indicator. And this is for steering. If this is used to control the manual and automatic mode. If the manual mode is turned on, the steering manual will be turned on, and we can using the steering knob, we can control the steering manually. And also we used some LED to indicate the manual mode is on. Before explaining the block diagram, we need to see the fuzzy logic. This is the fuzzy logic designer. Here we given an input of left, right, magnetometer, straight sensor, and camera sensor, and we given output values for steering and motor. These are the fuzzy logic, and these are all the rules I given to the fuzzy system. This is the test system of our fuzzy system. We can change the values to change whatever the reading is. You can see this for motor, camera. Now I am going to explain the simulation of the LabView. Here we can toggle the manual and auto mode by clicking this one. We have to give the string for this one. We can give 5 strings in a caps, or we can give any we can give the Arduino output also. If we give the string value, the ultrasonic values will be changing, and also the light value, because we are giving the last two values are for light. This for light lever, and also for motor speed we can control, and we can get the string values also. And also for steering it doesn't work because we didn't turn on the manual. If we turn on the manual, it will be working. After toggling off, it will be turn on the autonomous mode. For autonomous, we have to give five inputs. One is for left, right, straight, ultrasonic sensors, and for camera input, and also the magnetometer input. If we change the ultrasonic sensor values, any one of the ultrasonic sensor values, you can see the speed is also dropping, and the steering is also working. And also for straight, this is for this right ultrasonic, and also for camera input. And also this is for magnetometer. In here also we can take the motor speed string and given into the Arduino. Now we are going to see the MATLAB part. This is the code for neural network, and it is used to classify the images which is in the data set in the MATLAB. If we run this program, there will be pop-up screen displaying these numbers, and also we can see the training process, how the efficient the process is, and the process result is the validation accuracy is 98.76%. Here this code is used to classify the images. We are importing the two image into this code, and if we run this code, it will be categorized the two in the command window at the bottom of the screen. Now we are going to see the Arduino codes. This is the master code. This for setup on main programs, and for this one is ASCII values. This is light ultrasonic sensors, functions, magnetometer functions, neural network functions, servo control, and DC motor function. This is the end of the master code, and next one is the magnetometer. This is the calculation for a magnetometer, and next one is the camera. This is camera code, and that is the end of the video. Thank you.